All right, I actually haven't showed in code how I would add this. We should probably add to back. That's always a good thing. Right, what do we have? We had pushback. Let's do pushback. That sounds great. Everyone okay with doing pushback? Sure, okay. You know what, I take that back. We're doing push front. It is going to be easier than pushback, and then I'm going to show you how pushback is really easy as well. So let me go ahead and get this header all typed up for y'all, but I want you all to start thinking about it. What do we need to do for push front?
Like have it send it up.
We just need the address of the first element.
Yeah.
Well, push front, we're pushing a value. So we're a linked list, we're in a linked list situation. We want to push the value. Let's say we're up here on the code, and we want to push front the value 9.
Would that be a big O of 2? Or doing it?
There's only big O of 1. There's no big O of 2.
There's no?
No.
Big O and.
Big O of 2 is O of 1. If it's constant, we call it O of 1.
Would that be an O of 1 then?
Why would you say that?
Because you don't have to go through each and every elements of the list. You just have to just put that in a random location, and have that as a set, and then have it point to the first.
Correct.
The next.
That's why it's O of 1. You got it. But before we do that, what's the first thing we need to do? We want to put 9. What do we need to do first? We don't need to move anything.
We gotta get to the front. We gotta find the first.
We have the front. That's head.
So we need to make a head point to our new first element.
Well, we can't have it point to the element because head points to, well, what does head point to? Right, so what do we need to create? Right, we need to create a node first. First thing first, create the node. Let's create that node. So, SLL node with a capital N, sub T, we'll call it star new node equals new SLL node of whatever type that is, and we'll give it the val, and we'll have it point to null at first, just to begin with. All right, we have our new node. It's called new node, yes. No, go ahead. Okay. I'm doing it piece by piece. We'll make it more efficient. You might have caught something. That's fine. All right, so we have our new node. What do we do next? We got a node. I'll even label it new node for y'all.
Point to what head was pointing to.
Okay, so we can have, right now we have point to null. So yeah, we want to have it point to where head is, correct? All right, let's go do that. Great, so it's pointing to head. Oh, let me let you look at that. It's mnext, copy the address of head into it. So now it can point to head. All right. Perfect. Now what do we need to do?
Have head point to it.
Okay, good. All right, we can do that. Oops. Head equals new node. All right. So when that happens, we're having head point here. What haven't we done, guys?
Set a value.
Set the value right. We need to set 9 right here. Well, actually, we already did that, didn't we? Inside this constructor. So it already has a 9 because I did it in the constructor. Great. Can we simplify this just a little?
Yeah,
Was it
put
nine
head
already?
instead of no.
What's that? Yeah, put in head instead of null. Correct.
Put after head, put
Because then it automatically sets the head, right? It makes this superfluous. Because we set the new node to have the value and then point to head in the constructor.
So does that automatically change, make that the head then?
No. To make it the head, we had to call head equals new node.
Okay.
And if we wanted to get really, really, really fancy, we could have done this. New. And then all of this code is superfluous because you're going to create the node with the head pointing there, and then once you return it, you're going to set it to head. But that's probably confusing right now.
Where is it setting the value to 9?
So let's not do that. What's that?
Where is it setting the value to 9?
To 9?
9.
Right here in the constructor. Remember, this calls the constructor, aka this function right up here, and
So
sets inval equal to val.
9 is a
It's what I passed into it, which I haven't done yet. How about this? Push back. Except I haven't even written the node. I just called it. This is not even making sense. Ha! Someone should have caught me there. So let's do template class T class list public. Let's go and do private. We'll do SL node head. Beautiful. And then public will have, well, it's this guy up here. And we'll go over to CPP, and then now this is yeah, that makes sense. All right. And we'll go ahead and do another constructor void. What do I do? Sorry. Oops. Go and create the constructor for it. Did I call it imhead or did I call it something else? Oh. And then this needs to be, of course, imhead. All right. Now, if we type that all correctly, we can do this. Not quite. Inval used to template it without an argument list. Correct? Did we not put a list? We did not. Let's pass the parameter. Perfect. Okay, so I make an SL list. I make its first element SL node of type T. Notice I am passing the type from my SLL list class to another class called SLL node. Okay. Constructor and a push front. Constructor just sets head to null. Push front is going to create a new node pointing to wherever head is pointing to, and then update head. Is this going to work when head is empty? Well, yes it will, because the new node will point to null, which is what head is, and then head will point to the new node. So yeah, it's going to work. So let's go ahead and do list push front 10, which is what we did up there, and then let's do push front 9. Let's see if we got any seg faults. No, great.
Yeah.
Okay. Oh, this is rover. All right, sure, we'll do rover. Very, very helpful function you should always implement inside of your data structures is a print function. How can we do print? Anyone think about it? What can we do? Okay.
Print that value out to dereference point and then get that to show. Then go to what it's pointing to dereference it.
Okay.
And
Okay. So what's the first thing we need to declare? Because you're saying, let's go back to our picture. All right, now we're in print. And we're going to call dot print. And what are you saying we need to do?
Print out what head is, like, go to the memory address of head and print out what's there.
All right. That's the correct idea. Anyone have an idea about how we're going to go about doing that? Do we want to move head along? No, because you don't want to change its structure. So what do you need to do instead? I feel like y'all are saying it, just not loud.
Call SLL.
SLL. This is a SLL list, or a singly linked list.
Would you have to call the main list instead of the head?
So we need to start here, right? So we need to somehow have a pointer going here that can then point to the next one, who can point to the next one, who can point to the next one. Okay? So we need, and I'm going to call it rover. We'll have rover point to this first guy. You see where I'm going with this? All right. So SLL node, because we're pointing to nodes, rover, and where's rover going to start? Yeah, M head. When do we stop printing? Because we're going to set up a loop, or null. Null. So while rover does not equal null, we're going to print it out. Rover, I think it's M data. We'll go and just put a space afterwards. But afterwards, what do we need to?
Wait, is it well?
Yep, mval. I chose mval today. Thank you. Right, so we need to update rover equal to what?
And next.
Rover's m next. And then once that's done, or actually not rover. All right, there's a little error here. Hopefully it'll, or there's not. Oh no, because I didn't call the function. Yep, there it is. Mval is private within this context. All right, I know this is annoying, but it's just how you do it. And I'm just going to code it right here. And it's actually not T, it's so I can get the value and get the next. That's all. I could also just make it public.
It is public.
You want to just make it public? I bet you do. No, it's not. It's private.
Oh.
This is just how OOP works. It's extra coding, but it's better in the long run. There we go. 9, 10. Okay. Y'all see how this worked? Rover started here. Whoops, let me go to the screen. Rover started here, printed off the 9, then went to next, jumped up here, printed off the 10, went to next. The while loop ended because rover is now null, and we exit the loop, exit the print function. Okay, what's the big O of push front? Coming over here, push front. O of 1. We never have to shift anything down. All right, that makes life better. All right, so operations are going to talk about search, insert, delete, and traversal. We just talked about traversal. Good. Node, great. Oh, insertion. Let's do a couple more insertion routines. Let's do push back. Anyone think about how we would do push back? Yes?
You could have a private variable called entail that refers to the ending.
You've been reading, haven't you? Right. This actually makes life a lot easier.
What happens? Very good.
Well, not easy. It actually makes it more difficult, just more efficient. Tail. We're going to have a tail. One points to the head, one points to the end of the list.
Now we can go back and forth.
Yeah. Ooh. So let's first update our constructor. Heads equal to tail, which equals null. They're all null. Now we need to look at push front. If we're pushing to front and tail and head is the last, like it's the first one to be element added, we need to update tail, right? So we need to add a little, whoops. If tail equals null, tail equals head. If this is the first element added. Because if it's the first one added, you need to make sure tail points to it as well. Now notice at this point up here, we have head up here, and we would have tail right here. Whenever you add another data member, you have to go through every single one of your functions and make sure you're not messing things up. When you do print, do we need to do anything with tail? No, it doesn't manipulate tail, so we're good. All right. Where's my code? There it is. All right, so how would we push to the back? What's the first thing we need to do? Create a node. And this new node's going to point to
Tails,
next, which is
the current.
which is always going to be null, because if you're at the end, your next is always null. All right, so we created that. Now what do we do?
So tail points.
All right, so tail, yeah, we're gonna need a set function. Set next to the new node, right? Let's go ahead and put that in real quick. Void set next. Okay. All right, so set next, great. Then what do we do?
Do we also need to make it so that the previous last element now points to this one?
That's already been done, hasn't it? So let's go look at the picture real quick. Let's say we're up here and we're gonna pictorially. By the way, guys, if you're having a hard time understanding what's going on, draw it out and make sure your code is matching. So we're doing a pushback of 11. So first step, we created a new node. We put in 11, we have it point to null. That is this line right up here. Create a new node with the 11, set it to null. Let me go ahead and type that in the code real quick so y'all see what I'm doing. Push back 11. Okay. mtail-next equals new node. So I'm saying that mtail, what's currently at the end, he's going to go to the 11.
Okay, I misunderstood it then. Then we just need to set the tail pointing to that.
Right. So he's already pointing upright. The picture always helps. So now we just need to update mtail, right? Okay. Oops. mtail equals new node. All right. And that will make mtail point to this. We're almost there. There's one huge error with this code.
Those pointers we didn't delete.
I always want to do that, like have some balls and just start pummeling when people fall asleep.
I'm sorry.
But what do we need to do next? Add to the, oh, whoa, no. What else do we need to do with pushback? Pushback is not correct. say it's correct for that situation up there. There's another situation we are missing. If the head's null, what's going on?
There's no elements.
Yeah, there's no elements. So, right. We need to update if we did it down there. If mHead equals null, then mHead equals mTail. Otherwise, we'd have mTail pointing to something and mHead not pointing to anything. That wouldn't make any sense. We'd have errors. Bad things would happen. Sadness, right?
That was actually a total guess. I'm still shocked.
No. What did I just do? All right, let me put in a comment real quick. If the list was empty, update head. All right, good. What is the big O of pushback? O of 1. How's the linked list looking versus the vector? Pretty good, yes.
I was just not sure that if mHead was null, like there were no elements in the array, when mTail was also 1, how could we set next? How could we call the set next function for mTail?
Good. That's right. If mTail does not equal null, we'd get a glorious seg fault. Right? Wouldn't we? Because if mTail is null, bad things would happen. Then it's just to the new node and we're good to go. Do you make the mistake in the mHead? No, I don't think so. Yeah, because we don't need to set that pointer. It's already made in the constructor. Yep, good catch. That would have been fun. All right. So linked list is looking pretty good. How do we get the ith element?
Do we do like a loop?
Yeah. All right. Let's go down here. We'll call it get at position int pose. All right, let's see. Actually, did I run this? Let's run it. Nope, I'm wrong. I didn't run it to make sure the code was correct. Wow, that was silly of me. All right, so that's been defined. Let's go over here and fix my coding mistake. Come on, guys, semicolon, really, no one? All right, 1911. All right. Get a position. What do we need to do? Right, what does this sound like? What other function did we do this before? Print with our, you're going to be typing rover a lot in these labs, guys, unless you want to call it something else, which I don't recommend. I'm going to stick with the format I'm doing it. You could put it all inside of one for loop, but this is probably clear, so we're going to leave it like this. While rover does not equal null, rover equals rover dash next. All right, but how many times are we going forward? I. Yeah, so it really is a for loop here. All right, we'll do that. Int I equals 0, I is less than pose, I plus plus. And we'll also put in this rover equals rover dash next. Okay. I'm going to let y'all tell me what to do next.
Return rover.
Okay.
Rover.
Yeah, return rover get. Did I say get value? Get val. All right. Which also means this has to be get next. Okay. All right. Let's see how good that is. We'll do. going to comment this stuff out up here. Let's see if we type that correctly. Not yet. Oh yeah. List is a pointer. We can't use dots. Ooh. Ah, C++. Failed because it's returning. Oh, did I make it a void? Oh, that was silly of me. What should it be returning? You see what was that, Peter?
Well, in the for loop, shouldn't we have another condition making sure that if rover is pointing to null, it doesn't try making I go up again?
Ah, everyone hear that? What? Hey, let's make a test case.
Because if I is bigger than
100.
it'll
What's
try
going to happen?
next.
Yeah.
It's going to
Try to
say
get the next one.
There you go, seg fault. Oh, seg fault. What just happened? Well,
try getting the next.
right. We tried to increment rover equals rover dash next, but rover right here is null, which equals seg fault. So,
We also in condition I is less than POS
sure.
is-
If yeah, this is going to be kind of weird. Because then also, what are we going to return?
Wait, why are you doing I outside of
You
loop?
know, you can just do where I is less than POS.
Okay, all right, sure.
For loops, you can just do an and.
Okay, all right, well, we're doing, I heard different things, that's fine. And rover does not equal null. Okay. Oh boy. All right. But if I call this, oh, another seg fault.
Like what? You did.
Yeah. Well, I mean, rover's null, and then I go down here and I call null dash get val. Probably not what we wanted. So if here is where it's going to get really hard. We could try to return null. But that would work for integers, wouldn't it? No. No.
What's the null version of null?
Maybe like return
We could cast it. This is going to be fun. Hey, it worked that time.
to avoid errors. Maybe like return the tails values.
Yep. This is not an easy problem to solve.
Yeah, I can tell.
So let's change it up. Let's make it return a pointer. So now we can actually return null. This is one way to solve this problem. Of course, now we need to dereference this. And obviously, if we try and dereference 100, it's not going to work. But you know what? That's still fun. Oops. L value required in unary something or another. Oh, that's because we can't get that. Oh, that's right. Oh, C++, you have killed me. Wow. Hold on a second. Well, I'm trying to remember how STL did this. Oh, yes. What the STL did instead, and does this even make sense here? The STL actually did this. I'm going to show you what the STL did. They let you segfault. What? If you create a vector, I'll show you. Yeah. Yeah, this is let's do a tab. I agree completely. I'm going to call it sadness.cpp. Vector. Oh, you've noticed that, eh? People need to realize that sadness occurs. We'll create, I don't know, we'll do a vector of integers, call it vec, we'll have a size 10. And normally you do vec sub 0 equals 100, and then you can do, and this is perfectly fine, as long as I typed everything correctly. So let's go ahead and compile sadness real quick. Okay, fine. Yep, the good old IO stream. Good. 100, beautiful. Well, what happens if I do a vector of 100? Or let's do 1,000. Oh, it took it. Wow. What if I did, made some strings? I wonder what's going to do here. I was actually surprised that happened. Returned nothing.
Is it like returning a default value?
It's returning a default value. Yep. So, if that's what it's doing, then that actually implies that we can do this. Or actually, of 0. Oh no, it would be just this, I'm sorry. Right, let's go fix that real quick. Doing a little C++ reevaluation. Hey, it took it. All right. So we'll stick with the This is still sadness, though. Why is this sadness?
No, now you don't even know that it's an error. You just
Right.
see that it's producing incorrect output.
Yeah, this is even worse than segfault, guys. This is worse than segfault, because now it's just giving you a value and moving on. So your error, you may not get an error until line 500, but your real error was in 3 files over on line 23, but there's no way that the compiler could tell you that.
So how would you even write it? You just have to know that.
Well, 1, always write correct code, right? Don't mess up. And 2, you're going to get used to how to use a debugger and watch the code move around. You have to like put display variables up, watch them all change, and eventually you'll see, huh, why did I get nothing from here? That doesn't make any sense, and you have to go back up the chain. All right, well, that was fun. Okay. Actually made that a lot easier. All right, what's getting the ith variable in a linked list? O of, remember, n is the number of elements. Let's say on average it has to go halfway through the list. And be divided by 2, which is still O of n. Huh. Interesting. Although, if I were to do a get first and get last, what would be, we'll do it right here. Get first. Let's get, if I were to write that function, what would it be in an array? O of 1. What would it be in a linked list? O of 1. How about get last? O of, no, you just jump right to it. I mean, if, yeah, you can just get the any ith elements O of 1 and just get the last ith and it's still 1. How about of a linked list? O of 1. Okay. We'll talk about remove later. But here you go. Look at that. Here's the big difference between the two. Adding to either side of a linked list, super fast. It's trying to get a random value that is slow. The exact opposite is the case with an array. Y'all see the difference? Excellent. Wow, we've been burning time. Okay. I don't even know. All right, hang on a second.